Okay guys, so what we're looking at today is actually going to be probably the toughest part of this unit. And it's not that it's that bad, it's just it is a little bit of a trick. So the first thing we're going to look at is we're going to try to remember back to geometry a little bit. So we've already used the law of sines and cosines, and as you guys have realized, there are certain times when I can use the law of sines, and there are certain times when I have to use the law of cosines. So for example, I had to use the law of sines, or I could use the law of sines basically anytime I had two angles given. So if I knew an angle on two angles, let's just call these B and C, if I knew those two angles and I knew the side in between them, which would be A, it was okay for me to use the law of sines. I could set up that ratio. It also would have worked if I was given those two angles, and instead of the side in between, if instead I was given a different side, like let's say side B. In either of those cases, it was okay for me to set up the law of sines because I had enough information to write those proportions. So if you look back to geometry, if you remember, if I'm given two angles and the side in between, that was angle, side, angle to prove triangles were congruent. And the other one would have been angle, angle, side, which helped me prove triangles were congruent. Now, we're not going to have to know what these names are. It is going to be helpful, though, to be able to recognize when I can use the law of cosines and when I need to use the law of sines. Now, the law of cosines, there were two different cases that I used it. The first one was the simpler one, and that was when I was given one angle, let's call that angle C, and the two sides next to it, which would be sides A and side B. So if I was given two sides and the angle in between, it was really easy for me to use the law of cosines. The other case was the tougher part of the law of cosines, but I was also able to use it to find an angle if I knew all three sides. And again, if you guys remember from geometry, those two congruencies were side, angle, side, and side, side, side. Alright, so there's one other thing you learned when you learned about triangle congruency proofs, and that was that there were two cases you could not prove triangles were congruent. And the first of those was angle, angle, angle. So if I knew all three angles on the inside, there's no way I could solve that triangle. And the reason for that, it doesn't matter what information I was given, I could never solve that triangle because there's really an infinite number of possible answers. I would have to know at least one side in order to solve a triangle. So I can never solve a triangle with only three angles, just like you couldn't prove triangles were congruent with all three angles. Now the last case that we haven't talked about is the one that's going to come up today. Now we couldn't use it to prove triangles were congruent, and the reason for that was because there were two different possible answers. And that's going to come up today because we're actually going to see that there is sometimes a possibility for two different answers. So the case we're going to look at is if I'm given, let's say I have a triangle, and I'm given an angle, but instead of the two sides next to it, I'm given one side next to it and one side that's across from it. In this case of congruency, if you guys remember, this was known as side-side angle, because we couldn't write it the other way around. We had to write it a side-side angle so we didn't get in trouble. And we could not use this to prove they were congruent because there were two possible triangles I could make. So what's important here, it is two sides at an angle like we used for law of cosines, but again, what makes it different is that the angle that I'm given, the angle is not between the two sides. So whenever I'm given a triangle like this, I can still solve it, but this is what's known as the ambiguous case. Because there's a couple different things that could happen here, and that's what we're going to look at today. Alright, so we're going to work a couple of examples, seeing all the different things that could happen if I'm given this type of information. Alright, and I am going to use the law of sines in order to solve this, but we're actually going to explain why there's actually two different answers that could occur. So the first example I'm going to look at, whoops, I went too far. Let's go back. Having some trouble with this. Let's see. I'll have to skip that second slide. Sorry, guys. Okay, so if I look at this very first example, I'm going to need to draw a triangle for this. So I'm given one angle, and I'm given two sides. But again, if you look, let's go ahead and draw this. This is going to be x, triangle XYZ. I know angle X is 27. I know side Y is 5, and the side across from X is 4. So this is side-side angle, which means this is going to be the ambiguous case. And in order to solve this for the measure of angle Y, I'm going to start setting this up with the law of sines. So if I want to solve for angle Y, I know that the sine of Y divided by the side across from it, which is 5, has to be equal to the sine of 27 divided by 4. So I'm setting this proportion up just the same way I always would. So in order to solve this out, I'm going to cross multiply and divide. So I would get 5 sine 27 is equal to 4 times the sine of y. So to get the sine of y by itself, I would divide by 4. And I would get that the sine of y is equal to, remember I should still be in degrees here, is equal to 0.567, and that decimal is going to keep going. So to get this exact, okay, I'm going to use the second answer on my calculator to make sure I have the exact value on there. But remember, in order to find angle y, I have to rewrite this as an inverse. So I'm going to do sine inverse of my answer of that 0.567 number. So when I do that in my calculator, that's going to give me 35 degrees. Now the reason that this occurs with the ambiguous case is because if you guys remember, when I do an inverse in my calculator, it gives me the principal value. But there actually is a second place where that could be true. And that's where our problem occurs here. That's why we couldn't use this to prove triangles were congruent. So if I were to think about that, I know that sine gives me a positive value in the first quadrant. Sine is also positive, though, in the second quadrant. So if I have that reference angle of 35 degrees, another possible answer here is however much that full angle is. And that full angle could also be 145 degrees. So that's what's going to make this a little bit more difficult for us. Okay, so there's actually two possible answers here. So that means for the next part, I'm going to solve for side z. So now that I know my missing angles, I can actually solve for this. However, the first thing I'm going to need to do is I'm going to need to draw my triangles. And there are two different triangles that I'm going to need to draw. So the first one I'm going to draw is using my first answer. So no matter what, triangle XYZ, x is still going to be 27. Side y is going to be 5. Side x is going to be 4. But the first case here is going to be the first one I found, and what the calculator gave me that angle y was equal to 35 degrees. So I'm going to set this one up first. But then as we know, there's a second possible answer here, so I'm going to draw another triangle. So this other triangle is going to have the possibility where I still have XYZ, I still have 5, 27, and 4. But angle y in this case is going to be a little different. Angle y this time was my second answer, which was 145. And that's going to change angle z for both of these triangles. Now I know on both of these, all three angles have to add up to 180. So if I subtract 27 and 35 from 180, that means that the measure of angle z in this case is 118 degrees. And I know on my triangle over here, again, if I do 180 minus 145 minus 27, angle z is going to be 8 degrees. So that's just going to set up two different scenarios for the law of sines. So on my triangle on the left, I would do the sine of 118 divided by side z equals the sine of 27 over 4. But on the right triangle, I would have to set up a different one, and I would have to say that the sine of 8 degrees over side z is equal to the sine of 27 over 4. So it's the same formula, it's just a different possible angle. And when I solve these, I'm going to get two possible different answers for z. If I work this out on the left, I would end up that side z is going to be 7.78. And if I work it out on the right, I would get that side z is equal to 1.23. So either of these are possible for side z. Okay, so that's one possible occurrence when I'm given side-side angle. That's the reason, again, we couldn't use an approved triangles are congruent. Now, there actually are two more cases that we'll need to look at that could occur when I use the law of sines in the ambiguous case. Alright, and those are, let's start with the triangle on the left. So I'm going to redraw this triangle here. And this is going to be xyz again. Y is still 5, angle x is still 27, but this time side x is 6. So I'm going to set up my law of sines. Yeah, it's telling me to solve for side z. But in order to solve for side z, I'm going to need to find angle z. And in order to find angle z, I'm going to have to set up the law of sines for the only angle across from a side, which is y. So I'm going to do the sine of 27 divided by 6 is equal to the sine of angle y divided by 5. So if I solve this proportion, if I divide and cross multiply, then I would have to take an inverse again. I would be doing sine inverse of 5 times the sine of 27 divided by 6. And typing that in my calculator, that gives me an option of 22 degrees. And that's for angle y. But as we know, sine can also be positive in the second quadrant. So if I do 180 degrees minus 22, I also have the option of 158 degrees. Now the problem with this, if I have a 27 degree angle already, if I add that 27 degrees, it's already going to be more than 180. So that means in this case, even though technically I could find a second answer, there's no way I could build a triangle with that second answer. So the only option for angle y is 22 degrees. So what I'll do now is I'll just continue to solve this triangle for side z. So now that I know that angle y is 22, I can subtract 22 and 27 from 180, and I get that angle z is 131, and that's the only option because the other option didn't make a triangle. So now I'm going to set the law signs again, and the sine of 131 degrees divided by side z has to be equal to the sine of 27 over 6. Cross multiply and divide, and I get that the sine of z, the only possible option, is 9.97. Alright, so there is one third option that could occur whenever I try to set up the law of sines with the ambiguous case, and I think you guys are going to like this one. So I'm going to draw my triangle. It's still xyz. Y is still 5. Angle x is still 27. But this side x, is 2. So again, if I'm trying to solve for side z, I need to determine what angle y is first. So the sine of angle y divided by 5 has to equal the sine of 27 divided by 2. So I'll cross multiply and divide, and as I do that, I'll get that the sine of y is equal to 5 sine 27 divided by 2, which is 1.13. And if you try and take an inverse to this, there's going to be a problem. As you guys know, it's going to give me an error on the calculator because I cannot have the sine of an angle be greater than 1. So what that means for this triangle is there's actually no solution possible. It's impossible to have a triangle with the information that I have given. So in this case, there's no answer. So there are three possible cases when I'm given side-side angle. There's either no answers, one answer, or two answers. And the biggest thing you guys just need to remember is anytime you do a sine inverse in your calculator, check for that second answer. And as long as you do that, you'll be all right.